All right. Good morning, folks. Thanks for popping in. I appreciate it today. Today, we are going to be going over something called an ILM. And what that stands for is Individual Learning Module. If we were to take a program at SAIT, say welding, you'd be required to purchase some course packages. And for each section of the course, each thing they teach you, they have what's called an ILM. And today we're going to be looking at the weld joints and types ILM. I was fortunate enough to be able to get a copy of these from SAIT, and I have the version here that we're going to use for today's exercise. So we're going to go over this. We're going to familiarize ourselves with an ILM. I do have a full set of these, and I use them throughout my lessons here and there. I don't really focus on them heavily because they are designed for a first year welder. And so some of the language is a bit advanced. The teachers that teach it are specialists in their field. I am more of a welding generalist. If you need to learn more about each of these subjects, you can do more. You can do that at SAIT. I don't need to drill everything into you and have you know all the fine minutia of how processes work. That's their job. My goal here is to create some interest in the program and maybe show you a cool skill that may help you out later in life. So what we're going to do is I'm going to share my screen with you here. And then we are going to have a look at this. So this can be found under semi-auto and auto welding. What I've done is under weld positions and joint types. We've worked through a few other things already. So we had the PowerPoint, we had the weld position symbols PDF, the weld joint types PDF, which we looked at yesterday. And yeah, sorry, just one sec, guys. Oh, no problem. We're good. Today we're going to look at the student version of the basic joints and weld types. So we're going to click on this one here. You won't be able to see this one. It's the teacher version. It's got some notes in it, stuff like that. We're going to see this one. This is one we're going to work with today. So we're going to pop this out. We're going to put it into, open up in Google Docs. Actually, no, we're going to look at it just like this, because this is nice formatting. In Google Docs, I think the formatting comes off a little bit, so you'll have to see where it works best for you. But each module here is going to have the Alberta apprenticeship symbol on the front. It'll give the unit. We teach this in shielded metal arc welding 1, first period, which means first year welder. They're also labeled 1, 201 or 02C. There's all sorts of different numbers and stuff like that. The one is basically just for first year as far as I recall. But they're going to be set up in booklets, digital files, whatever you might be able to purchase them in. When I did this, I physically bought the booklets. So what happens here is, you know, they go through all of the beginning stuff at the front, publishers, blah, 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 table of contents. This is really going to help you out here because we're going to be working with these ILMs, and they are going to just be useful to know how to navigate properly. So what we have here is Objective 1 talks about the 5 basic joints. Objective 2 is the 4 weld types. Objective 3 it goes over each of the joints. Then it goes over position designation for groove and fillet welds. So knowing the difference between groove and fillet is going to be quite important. Objective 4, considerations for good joint design. It's how do we make this as strong as possible? And then we have the self-test and the self-test answers. So that is what we're going to look at here. So we're going to just quickly flip into Objective 1, the 5 basic joints. Now we went over this yesterday. This is more or less just reinforcement of an idea. And then there will be a quiz on this probably on Friday, maybe Thursday. It's 10 questions. It's not that big, but I want everyone to have a chance to complete this. So we have a rationale. This is why is it important for you to learn this skill? Well, welded fabrication, it's of great importance that the joint type be carefully selected. For example, at some point in your career, you'll likely encounter a joint that is impossible to see or even to get at to weld. Obviously, this person who designed this joint has not considered whether it is accessible for welding. This is a big mistake. I've come across numerous things like this in my welding career. Some are quite difficult and very tough to reach. There was one that really stands out in my mind where I actually had to weld 4 welding rods together and create a 4-foot long welding rod so I could reach up inside of this space between 2 columns to get back to where I need to weld. And I couldn't hold it, so I had to jam a board underneath it and lever off of that board to get my rod to work where I wanted it to. It was really quite silly. Definitely not ideal as far as welding goes, but that's what had to happen. This is a perfect example of one of these joints that was very difficult to weld. So we're often given the decision on how to prepare a joint. It all really depends on how strong does it need to be. There's a few factors you have to take into account. What's it doing? Is it going to be visible to the public? Is it going to be a hidden weld? Is it going to be taking a lot of forces? Even salt air conditions we have to consider. Whether we put a galvanizing on the weld or how we finish that weld. So, all right. So outcomes, objectives. So the objectives here just basically go over what this section of the module is going to teach you. And here we're going to talk about the 5 basic weld joints, describe the types of weld and their acceptable dimensions. Dimensions are important. Identify joint and weld type variations, because it's not just 5 different weld joints. There's so many different variations, but they're all iterations of the same thing. So if you know the basics, you should be able to understand the majority of the different variations. And we're going to outline the major considerations to be accounted for in the design of a joint for welding. So why we do what we do, or why it's prepared the way it is prepared. So I'm just going to flip here quick. Objective 1, we'll be able to identify the 5 basic joints. As we know, we got the butt, the lap, the corner, the edge, and the T, or BC TEL, if you were paying attention to yesterday's slideshow yesterday. Objective 2, when you complete this, you'll be able to describe the types of welds or acceptable dimensions. We have 4 weld types here. We have surfacing, we have plug or slot, we have fillet, and we have groove. And we used a statement yesterday that was, some people find gold. So S for surfacing, P for plug, F for fillet, G for groove. Some people find gold. That is what's helped me remember that. All right, so also we have surfacing welds. So we're going to go over those 4 different types. Surfacing is a buildup on the outside of a structure or a piece, and could be to replace worn material, or could be to build up material to be worn off. You can add material to things to make it thicker, called cladding, or you can do stuff like hard facing and put buildup on top of a new piece of material, or even an older piece of material, to prevent it from wearing out, to extend the life of it, and to overall reduce cost and expand the lifespan of this stuff. Because I was talking about yesterday, brand new loader bucket, 25 grand. You can wear that out in a few years, even do a lot of damage in a year if you're working with hard material. But you hire a welder in right off the bat, and you put some hard facing on it, you invest another $1,500, $2,000 into that bucket, it's going to last you much longer. That hard facing will wear off. Simply call up the welder again, or if you're the welder, you do it yourself, and you apply more hard facing to it. This just extends the life of your equipment, reducing your overall cost, which is good business. We do not want to be spending extra money if we don't have to when we are business owners. So plug or slot welds, if we want to join these 2 pieces together, if we cut a hole just like this one in the top of the top piece, and we weld down through to the bottom piece, slot welds are just a variation of a hole. Just an extended hole is all the slot weld is. So you can see them there and there. Fillet welds, this is what we're going to be working with. It's the T joint right here. This is the lap joint right here. That's what we're going to be working with in class. Those are good to know about. Corner joint. There's lots of different ways of fitting up corner joints. It all depends on how it needs to be welded and what you have access to. So right here, gives a lot of good information. I know a lot of this is going to be on the test because I base the test off of this ILM. So what I'll have you do is I'll have you guys go through this, read this ILM here, and then what I'll allow you to do is allow you to have the ILM open, and you can use the ILM to help you answer the quiz. This will be tomorrow. I'm going to give that quiz though. Goes about how to measure it, the different parts, the anatomy. So we've got the toes of the weld, we got the face of the weld, we got the theoretical throat of the weld, we got the leg of the weld. A lot of body parts, or a lot of weld parts are named after body parts. Even got the face here, face of the weld. So, here's going to show some profile, some things we're looking for in a weld. So profile is the shape of it from a cross section. If you were to cut that weld in half, take a look at it from the side, what would it look like? So ideally, we want to see nice, even profile. No jagged, weird shapes, no big dips in our weld, no excessive convexity, no big kind of like beer bellies hanging over it, no undercut at the top, lots of different things. We're going to learn to control this, learn how to create nice welds as we start welding in class. But this here kind of gives you a couple of things to look out for and show you what is acceptable and what is not acceptable as far as weld profiles. Now, with you guys, I'm going to accept pretty much anything because you're learning, but say they're going to have a certain standard that they're going to want to see because they need to guarantee that you know what you're doing when you go out their door. With me, the stakes aren't as high. We're just learning and having some fun. So as long as you can kind of demonstrate concept and show me the basics of it, I'm pretty happy with that. Here, we talk about discontinuities in the profile. So discontinuities is something undesirable. And what we have here is a long leg on this side and a short leg on the vertical leg. We want both these legs to be equal. So we want the distance here, let's say that's X, to be the same distance as this up here, which would be X once again. We got variations of fillet weld. We've got continuous, so that's one end of the joint to the next. We have intermittent, which is right here, which means we do a bit, we leave a space, we do a bit, we leave a space, we weld a bit. We have chain intermittent, which is the same thing on either side of the piece being welded. So this would be mirrored on the back side. We can see that here. And then we have staggered intermittent, which is offset. No, not the Migos guy, but offset welds. So we have a little bit right here. Got a bit of weld there. And then on the opposite side of the plate, this weld would start where this weld ends, and then vice versa and vice versa. So we have staggered intermittent, chain intermittent, intermittent, and continuous welds. 4 variations of one style of weld. There's nothing different about the welding technique. It's just how or where you apply the weld on the joint. That's the only thing that's different. So talking about groove welds. So that's a joint between 2 plates. Generally, butt welds are prepared or have preparation. And that's what we're doing right now. So we're going to talk about that. Butt weld would just be slamming 2 plates of square edges together, which is fine if you're looking for absolutely no strength in your weld at all. If you're just looking to stick these 2 pieces together, then that works. But it's got to stand up to any type of stress, any loading, anything. You want to guarantee that you've got a strong joint. So we need to do some preparation. Most common we see in class here is going to be this looking one right here. And what this is a V-groove weld. They've taken a little bit down for the root faces here, but generally when we cut these on the saw, this angle is going to extend to a point, That would be a V-groove preparation. We talk about the groove angle in class here. It goes anywhere from 60 to 75 degrees. Basically, it just depends on what I find works best with that weld joint. Anything bigger than that, we're going to end up with quite thin walls at the bottom of the plate, and we will burn through. So 60 to 75 degrees is kind of where I run that. We have another groove here. We got a U groove. I often don't see these. I have, welded them before, but I often do my own preparation on a U-groove. So when I was doing a lot of repair, I'd be given machinery with a big heavy plate on it. That plate would have a crack, but not all the way through. So it's still in one piece, but it's cracked. You cannot separate that. You cannot do anything to it to use a machine to prepare the edges for welding. So what I would do, I'd use what was called a carbon arc gouger or an air gouger. And it has a round rod. And when you work that round rod and you do the cutting with it, it will cut a groove just like this one. So I would prepare those cracks with U-groove type preparation, and then I would weld them entirely. And I'd come from the back side, if I could get to it, groove it out again and put a weld on the back side to make sure I had 100% penetration from top all the way through bottom. And that helps prevent further cracking. So it's going to go over reinforcement, beads and passes, what a root bead is, what a face is, what a cap is, all those different things. It's going to talk about square grooves, double welded square grooves, different variations of these type of things. And we're going to see that's all going to continue with the different styles. And then we get to J groove, double J's. Objective 3, we talk about corner joints, how to set those up, different ways of setting them up, which is more effective, ways of preparing them. We talk about edge joints as well, where they're used, how they're assembled, where they should be welded. T-joints can be a very common one we see in class. Normally I do basically a butted up T-joint, a square T-joint, where we take this piece here, drop it right against this one, put a tack on the end. The tack is just a small weld to hold those two plates together. And that is a term we're going to be getting more familiar with. So I'm going to be putting up what's basically a welding word wall. There's a lot of terminology in welding that people are going to be unfamiliar with. So what I might do as a class exercise is have you guys look up and create a definition for a word that I create, and then we'll put it up in class for everyone's reference. So that'd be good to help everyone out. We got lap joints, we got butt joints, talks about all these different things here. It's not really a whole lot of reading involved in this, but it is going to take you a few minutes to go through it. So when you go to do the quiz, it is best to have this open in another window if you can access it, and use this to help you along in the quiz. Considerations for a good joint design, that's number 4, and basically it just talks about how to set yourself up to be or have the most success when it comes to welding, and to make sure that we're selecting the right type of preparation and weld for the situation, because every situation is going to be different, and some may require more preparation than others. Some may not require any at all. And here's a self-test. So self-test is going to be 26 questions. We don't have to do the self-test. So what I've done is I've taken 10 of the self-test questions and I've put them into a quiz for you. The quiz is going to be on V2L. We'll get into that tomorrow. I'll open that up for you. But for today, folks, I would like you to go over and just read through this here. Just get yourself familiar with it, how it works, just how to locate things on it, knowing that we have the table of contents to help us as reference. So that can be right here. I'd look and tell you where a lot of this stuff is. That's going to be helpful when doing that quiz also. So I'm going to leave you guys with that today. That is what I have for you. Basically, I want to show you around an ILM, how they're set up, what they look like, and what to expect if you're taking post-secondary welding, or even 20 level. I use a couple of these in 20 level, a couple in 30 level. Yeah, so thank you much for joining me today, folks. Please drop your names in the chat if you have not. Once you have done that, you are free to go for the day. We are looking at some marks. We're doing checkup on marks for kids. So make sure you have stuff done in your other classes. I'm trying to avoid giving you guys a whole bunch of work, just so you can make sure you can focus on your cores. Cores are more important than electives, so I do encourage you to focus on those. But equally, if you do have time, you find you're not being overloaded, please make a good effort to complete all the work I'm assigning as well. Credits are not free here, so you do have to earn them. You do have to pass the units, but I am definitely very reasonable when it comes to marking and accepting things. And yeah, I'm here for you guys to have a good time. I'm not here to basically test you academically, but I do need to know that you know some of these concepts. So that's why we have to complete the work that we do. So thank you much, folks. I want you to have a good day. Stay healthy, have a good lunch. And I will see you all tomorrow, and we'll go over that quiz, and then we will release it to you. Awesome. Thank you much, folks. Have a great day. Look at all that reference material in the Weld Joints and Positions unit. It's all there for you. Okay. Thanks, guys. Bye.